How are you, dear families of my channel? Welcome to my stoichiometry class. Uh, this class I'm going to show you how to calculate the volume problems. Under this category of stoichiometry, you should consider about the standard temperature and pressure. Standard temperature means 0 degrees Celsius and standard pressure means 1 atmosphere. Therefore, as these conditions are fulfilled, 1 mole of any gas occupies the same space, which is 22.4 liters. This 22.4 liters space, which is occupied by the 1 mole of any gas, is known as the molar volume at STP. Avogadro's law states that equal volumes of different gases under the same conditions of temperature and pressure contain equal number of molecules. By having this idea, we'll do many chemistry problems relating with the volume and volume relationship. What volume of oxygen will react with methane to produce 44.8 liters of carbon dioxide gas at standard temperature and pressure? First of all, what must be done is balanced chemical equation is must. Therefore, what is happening? Oxygen is burning methane gas. Any hydrocarbon compound burns with oxygen gives water vapor and carbon dioxide gas. Therefore, what is given and what is required? This one is given for carbon dioxide, that is 44.8 liters, and X is required. Therefore, X will be written above oxygen and 44.8 liters above carbon dioxide. And below this formulas, you should consider about molar volume times coefficient. This is also molar volume times coefficient. The coefficient of carbon dioxide is 1, therefore 1 times 22.4, but this one is 2 times 22.4 for oxygen. You will set up the proportion, that is X over this one is equal to 44.8 liter over 22.4 liter will be put like this ones. Therefore, solve for X. That means X is equal to this one times this one, that is 44.8 times 44.8 divided by 22.4. This is the result will be 89.6 liter of oxygen is needed in order to produce 44.8 liters of carbon dioxide gas. Another question: what volume of nitrogen reacts with 33.6 liters of oxygen to produce nitrogen dioxide? First of all, you should write the balanced equation. That means nitrogen burns with oxygen to form nitrogen dioxide. Therefore, what is given? The oxygen volume is given 33.6 liter, and what is required is the volume of nitrogen. Then write X above nitrogen, and below it this molar volume times 1, because the coefficient of nitrogen is 1. But this one is 2 times molar volume will be put like this one is X over 22.4 is equal to this value 33.6 over 2 times molar volume. Then set up the proportion. This finished. What is happening? The value of X. The value of X is equal to this value times this value divided by this value, that is divided by 2 times 22.4, and therefore the value of X is equal to 16.8 liters of nitrogen gas is needed in order to combine with 33.6 liters of oxygen gas. The next question: how many liters of sulfur trioxide is formed when 4,800 centimeter cube of sulfur dioxide is burned in air? Remember, this one means centimeter cube, means milliliter. 1 liter is equal to 1000 milliliter. Therefore, 4800 milliliter means 4.8 liters. Therefore, what is given and what is required? The given ones is sulfur dioxide. This one, it is 4800, means 4.8 liter of sulfur dioxide react with oxygen to form X amount of sulfur trioxide. That is, sulfur trioxide volume is required to be calculated. Therefore, you will put 2 times molar volume under it, and it's the same thing. That is 2 times molar volume. Therefore, if this number over this is equal to this number over this, therefore the denominators are the same. X is equal to this much volume of sulfur trioxide. The same volume of sulfur trioxide will be formed because the coefficients of these two formulas are the same, and the value of X becomes the number which is written or which is given for sulfur dioxide, which means 4.8 liter of sulfur trioxide will be formed. The other question number 3, how many moles of water vapor are formed when 10 liters of butane gas, which was this C4H10, is burnt in oxygen at standard temperature and pressure? Therefore, you put 10 liter above the butane, which is given, and X above water molecule. What is given, what's required? The mole. This is not the volume. It is mole. Therefore, we can apply volume molar relationship like mass volume relationship we were calculating in the previous classes, and we can calculate also mole volume relationship. Therefore, X over 10 is equal to 10 over 2 times molar volume, can be just solved as such. Therefore, X is equal to the 100, that means 10 times 10 over 2 times molar volume, and therefore X is equal to 2.23 moles of water vapor is formed by this reaction. This is the class for this time. If you do have any question, you can write and like and share for friends.